Welcome to our exploration of solar energy across different planets in our solar system. Today, we'll compare the solar energy received by a 1 square meter solar panel on Earth, Venus, Mars, and finally, Pluto. To understand how solar energy varies across these planets, we need to use the inverse square law of radiative flux. This law states that the solar irradiance, I, is equal to the luminosity of the Sun, L, divided by 4 pi times the distance from the Sun squared. Let's break down the components of this equation. I represents the solar irradiance, measured in watts per square meter. L is the luminosity of the Sun, which is approximately 3.828 times 10 to the 26th watts. And D is the distance from the Sun in meters. Now let's create a diagram to visualize the distances of these planets from the Sun. Let's start with Earth. The average distance of Earth from the Sun is 1.496 times 10 to the 11th meters. Plugging this into our equation, we get a solar irradiance of approximately 1361 watts per square meter. Moving on to Venus, which is closer to the Sun at an average distance of 1.082 times 10 to the 11th meters. This results in a higher solar irradiance of about 2,600 watts per square meter. Next, let's look at Mars. Mars is further from the Sun, with an average distance of 2.279 times 10 to the 11th meters. This greater distance results in a lower solar irradiance of about 586 watts per square meter. Finally, let's consider Pluto, which is much further out in our solar system. Pluto's average distance from the Sun is 5.906 times 10 to the 12th meters. At this great distance, the solar irradiance drops dramatically to only about 8.7 watts per square meter. Now let's compare these values to Earth's solar irradiance. Venus receives 1239 watts per square meter more than Earth. Mars receives 775 watts per square meter less than Earth, and Pluto receives a staggering 1,352.3 watts per square meter less than Earth. So, what does this mean for the usefulness of solar panels on these different planets? On Venus, solar panels would be highly effective, receiving nearly double the solar energy compared to Earth. On Earth, as we know, solar panels are already used effectively. On Mars, solar panels would still be useful, but they would only receive about 43% of the solar energy compared to Earth. This means we would need larger or more efficient solar panels to generate the same amount of energy. On Pluto, however, solar panels would be extremely ineffective. With less than 1% of Earth's solar irradiance, it would be impractical to rely on solar energy alone. In conclusion, the effectiveness of solar panels decreases significantly as we move further from the Sun. This suggests that for deep space missions or potential colonies on distant planets, we would need to consider alternative power sources to supplement or replace solar energy.